Hello, my name is Idyo Branta. I'm from Telkom University, and today I want to tell you about how to design circular pad, especially single circular pad for the microstrip antenna. So let's start. First, we have to open the new project. Okay, project template. We wait for a while. Ooh. Okay, choose the antenna, planar, time domain. Okay, we don't have to change it, just next. So we put the frequency mean because I want the middle frequency is 2.4 gigahertz. So I input 2.3 and 2.5. Select on the E field, H field, and far field. So we get the middle frequency 2.4 and next. Okay, we can create the name for the template. It's up to you. Just circular page. Okay, finish. Okay, wait. Nah, now we can create the modeling. You can put the parameter first, or you can just create the design first. Press the brick and press escape on the keyboard. We can create the ground plan first. Ground plan. We put the calculation. Maybe oh wait. I want to put the parameter first. For the ground plan, we call is WG or width of ground. The expression is 11. Oh, for the parameter, we can get from our project. This is the calculation. Now, you can get the calculation and the value for the specification from the journal, or you can calculate by yourself. I get the formula from the journal, and I already create the parameters of specification. First, we going to create the width of ground plane. The score is 27.2 millimeter. So we put 27.2 and enter. Because I want to create the ground plane is square, so all the shape is the same. Okay, go to the brick, press escape, ground plane, and for the x-min, we can create minus VG. For the xmax, VG. For the y-min, we can put min VG. For x, put VG. Okay, something like that. After that, we can put the HT, or in here it's called head of page or ground plane. It's the value 0.035. So it's D. For the material, I use PHC, PIC, yeah. And we preview first. So for the HD, we put 0.035. Okay. As you can see, it's already show. Can press OK for the ground plane. Yeah, it's look like this. Okay. Then we create the substrate. We choose the brick, press escape. We call the name is substrate. For the x-min and the other parameter, we also use the minus EG. Why we use minus WG? Because from the specification, looks for the shape is the same, the size is the same for with the ground plane. Yeah, 27.2. So create the WG. This is minus. Okay, for the Z min, wait, I forget. The Z min is HT and H. Okay, for the material, I choose VR4. That's Lucy. Yeah, and we can preview. So the H is 1.6. We can look at the my report tick of substrate. So in the substrate we have the tick, or this is the specification 1.6. This is the common to use 1.6 millimeter. So we press OK, preview, so looks, and OK. So it's already show in the CST. Okay, this is the ground plane, this is the substrate. Next, because I use to circular, so we don't need to press the brake. We going to the cylinder. Okay, the cylinder, we press the cylinder and press the escape. We call it page. Yeah, for outer radius, it's called A or R. It's up to you, because we just need to put the radius of my circle pads. Okay, the radius is 17.6. Okay, for the X min, we put the H, or the X max, we put the H plus HT plus HT. For the material is Z max. For the material is PEC. Okay, just preview. Oh, for the R, we put 17.6 meter. Okay, just click OK. If you want to change the specification, you can click the what do you want to change. For example, I want to change the substrate. Edit properties. If I break, edit. This is I want to change to be H plus HT. Preview and OK. So we change the thickness of the substrate. Okay, this is the page ground plane. Okay, this is our design, right? After that, the last item we will create is the fit line. We choose the brick, escape. We create the name fit line. For the X-min, we create 0.5 minus 0.5. Or maybe we can create the new parameter in here. We call LF, or length of fit 0.5. This is the common to use. Create fit line. For the X min is min LF. Wait. And for the Y min, we can choose minus VG because we want to create the fit line is fit to the substrate. Okay, in here for the fit. Okay, choose the PIC. So the material for the fit and the patch have to the same. Okay, preview. Oh, okay. Or for the that mean we use HT H plus HT for this HT preview. Nah, looks like this and okay. Oh, don't forget to ground plane. We also change to H plus HT, H plus S. No. Cancel. For the page, we use H plus HT. Okay. So the thickness have to same from the page and the fit line. Okay. After we create the both page and the fit line, we can edit. Add first. You press the page, go to simulation, and then modeling. Click boolean, add page and fit line. Press enter. So it will looks like this. Okay. Yeah. So that we have to create the port. How to create the port? First, we have to zoom to the fit line. Looks like the little fit line. Pick the pick face. Click double to the fit line. Looks like this. And then we're going to with get port. If you want to use automatically, you can go into macros, but I'm going to create them manually. If guide, so put in here 1.6 times 3. Also put in here 1.6 times 3, 1.6 times 3. This is 1.6. Okay. So the port will be create looks like this. Okay. Yeah. Our design is done. We can simulate, but before we simulate, because I just want to show the frequency in the middle. So we're going to fit monitor. We can delete for the another frequency. So we just control and click and also right click, delete it. So we just focus on the middle frequency. Okay, we're going to fit monitor. Okay, we can choose the 2.4. We can apply or age. We can apply as so or far field. So now I am going to use far field. Apply. Click OK. Nah, you can just set up solver to running. So I want to accuracy on minus 30 dB. I can apply and start. Okay, the our design will start. Just take a minute time to simulate. Just wait. Looks like this. If you want to, I already create the finish one, so I pause it. Yeah. So your result will be like this. No, this is not the good result. But if you get the bad result, you can uh, go to optimizer. So this is the bad result because I want to check the 2.4 and I get the return loss just like this. Yeah, minus 0.25 is not the good result because the good result is have to less than minus 10 dB or minus 9 dB. So this is not the good for the VSWR or VSWR. This is the result. This is the very very bad result because the good result is have to less than 2 or near to the 1. This is our VSWR as is 67 is not the good. Also, if we check the gain, yeah, this is our directivity far field. Uh, okay, can change to gain. Is our gain very very small, just 0.7. It's not the good antenna, but you can going to home optimizer, okay, and check on your uh, result. If you want to, okay, optimizer. So you have to check on the patch size. This is our patch size is a 17.2 because the patch size will be changed to get the our frequency that we want. Okay, and then we're going to the goals. If you want to get the your result, like me, I want to my result is less than minus 10 dB, so I can get the good result. This is minus 10 dB. Remove this. Okay, if you want to create your VSWR is less than 2, yeah, like this. You can just click apply and start. So it will going to simulation again. Wait until it's finished. Optimizer, it will took a long time. So this is my this is my result already optimizer. My return loss is like this. It is a good result because it's less than 10 dB. Look like this, minus 10.635. Okay, and my bandwidth is like this. You can just looks like in here. And we're going to VSWR. This is my VSWR. It's very, very good because it's less than 2 and near to 1. Yeah, this is my VSWR. 1.83. Okay, and my far field is like this. Can plot to the gain. Okay, you can check on the 3D version. So this is my gain. Looks the different from the 0.7 going to 2.7. This is the power of the optimizer. So I suggest you to use the CST Studio Suite because it's a lot of feature like optimizer. Okay, and you can get the result that you want like this. 1.8 minus 10. Okay, that's all tutorial for the design antenna microstrip. And if you want to know about the calculation and how to design, you can check the tutorial from here. Circular antenna design equation. Yeah, this is talk about a lot of antenna and GST. This is the and then the calculation, the material, and so on. So you can check another journal to create a new your antenna with the new calculation, with new parameter and new specification. Okay, that's all from me. Thank you for watching and see you. Bye.